Hello, everyone. My name is Levi Button. I am the training manager at PTV Group out of our Portland, Oregon office, and I'll be leading the webinar today, doing most of the talking. On the line, we also have Bill Cisco, who is our manager of urban planning and traffic engineering. He is also out of the Portland office. He'll be monitoring the chat and helping out with the Q&A at the end. And we also have Adam Lynch, who is our Vistro product manager from our headquarters in Germany. He is also in the chat answering and going to help answer some questions. All right. So today's agenda, we're just covering the basics. This is going to be the first of a multi-part series with Vistro that will be provided throughout the year. But today we're just going to be covering the real basic parts, like adding intersections, and then we'll be moving into configuring the geometry, entering existing volumes, creating signalization, and then again, like Adam said, doing our Q&A at the end. So what we're going to do is we're going to start with just entering the basic geometry, almost like an existing condition that we'll be doing. So we're going to be starting by how do we add intersections into Vistro, and then how do we configure the basic geometry for the approaches, crosswalks, and medians and turn bays and things like that. So what I'm going to do is I'm going to jump over into the software itself, and we're going to get started. So to start with, let's take a look at the interface. In the interface, we have, for those of you that have not used Vistro before, we have the network editor where we will be editing the different network elements and viewing our network here. On the side, Vistro has all of the objects that you can place in the network. We're going to mainly be using just the insert intersection button up at the top. We also have different zones and gates and paths for traffic impact analysis and signal optimization routes. These buttons will all be covered in a later webinar on the other topics. Down below, we have some graphic overlay buttons for different things like the different movement graphic overlays. We have intersection level graphic overlays and approach level graphic overlays. We'll be using various graphic overlays throughout the course of our webinar series. And then we have our workflow panel on the side over here, where we'll be going through the different tabs. You'll notice that the different tabs are shaped kind of like arrows to signal the recommended workflow that we'll be going through. And we'll just be following these three tabs today, starting with our intersection setup, then moving on to inserting volumes on an intersection, and then traffic control. Lastly, we have our network editor settings, our map layers up above here. I might be using this throughout the course of the webinar today, where we can configure different settings about our map. For example, we can turn the opacity of our network down to better see the underlying background maps. So if I'm going to zoom in real quick on these sample intersections that we have here, I can turn down the opacity of my network to better see the underlying internet maps. You can also configure what types of internet maps and what your visuals look like. You can turn the opacity of your internet map down so that you can better see your network, or you can change what the maps are showing, so aerials, road maps, or Openstreetmaps. Okay, so just looking at these basic, or at these sample intersections, these have already been fully configured so that we can take a look at what the workflow panel kind of looks like. Starting with the intersection setup tab, this is where we can see the different physical attributes that we'd add to the network. And then you would move on to your volumes tab, where you can configure your different demand inputs for the current scenario. This could be for the existing conditions, future conditions. You can see we have a section for traffic impact analysis, as well as other modes that we'll be covering in a future webinar. And then you can move on to your traffic control, where you'll configure your signal timing and look at your analysis of the intersection. Once you've completed the first 3 tabs, the analysis automatically happens. So you don't have to run a simulation or anything like that. All right, so what we're going to do is we're going to start by adding intersections. How do we add intersections to a Vistro network? It's pretty straightforward. You just need to make sure that you have the correct intersection type selected. So up in the corner, we're going to use this Add Intersection button. By default, it is set to Signalized Intersections, but you can see using this arrow that we can select between always stop controlled, two-way stop controlled, an uncontrolled or unknown intersection, and a roundabout as well. So here we're going to add 2 signalized intersections to this ramp terminal. And this, again, it's just a click the button once and then you can drop an intersection in. You can also copy and paste intersections by just right-clicking on the intersection, saying copy and paste the intersection, and it'll just copy and paste it side by side. Nothing is set in stone though. You don't have to, if you accidentally input the wrong intersection type, you can always change it later. That's fine. Once you have input your intersections into the network, you will want to connect the legs together. And to connect the legs, you'll just grab the end of the leg. You see that when you hover over an intersection, it has the different handles that you can grab. So in the center, you can reposition the entire intersection by selecting the handle in the center. You can also grab the handle at the end of the leg. So right now I'm just left clicking on this. I'm holding left click and I can drag this around. And we can hover over an adjacent leg and it will automatically snap together those 2 legs. It will also merge the geometry of these 2 legs. So if I were to hover and select this leg and drag it over this, you can see that the existing geometry on this approach for this intersection number 1 here was automatically extended all the way to the next intersection, the new intersection that we've added. All right, so once we have our intersection placed, it's time to start jumping into our workflow panel. So what we're going to do is we're going to start by moving to a different intersection that has already been placed in the network here. And we're going to go through the workflow panel for this intersection. This is, in my network, this is intersection number 3. You can move around by using the scroll function on your mouse. You can pull back on the scroll wheel to zoom out, push in. You can click the scroll wheel to pan around. Or if it's easier for you, you can just use the intersection drop-down selection up in the upper right-hand corner to select different types of intersections. So here, we're going to be editing the approach geometry of this particular intersection. For the basics, we're not going to be going through all of these parameters, but I'll be hitting the key big ones that you'll need for your basic network construction. In future PTV talks, we'll be going through the other specifics of the intersection configuration. So if you're ever wondering about workflow, where do I start? What do I do? A good workflow is always just to start at the top and work your way down. So here we have, we can define the intersection number, we can define the intersection name, the control type, things like that. I'm going to start at the lane configuration. And I'm going to be using this existing aerial imagery as, I'm going to be using the aerial imagery as a guide. So to better see that, what I'm going to do is I'm going to turn the opacity of my network down so that I can better see the underlying network. I can also use the Control A feature. This is the hotkey to do the same thing. One other thing I'm going to do is I'm going to change my aerial maps so that it only shows the road network, or only shows the aerials, so that there's just less visual noise on the screen. Okay, so let's start with the lane configuration. Northbound, it looks like we have a shared through right and an exclusive left. So to do the lane configuration, you'll click on the lane configuration of that specific approach. And you can pick between different preset lane configurations here. So we can find our lane configuration. Again, we have an exclusive left and a shared through right by just clicking the preset here. You can also select manually build up your own if you don't see your preset here or you want to quickly add a lane. So for example, I can find this preset for the southbound leg, a exclusive left through and a exclusive right, but we can see that this is actually a dual left turn. So I can just use this add or subtract buttons here to add in an additional left turn lane. This makes it very easy to do quick geometry edits to your network. For the eastbound, we're going to have an exclusive right turn, 3 exclusive throughs, and then a left. And then for the westbound, I did that in the opposite direction. So in this case, this has a dual left, 3 throughs, but one of them is actually a shared through right. And then we have westbound, we have this configuration. Okay, so once you have your lane configuration, I'm going to extend these legs out a little bit just so I can see the approaches. And I might actually turn the opacity back on my network, just so you guys can see what it looks like so far. So we've added in our lanes, and Vistro makes a guess initially at how many turn bays each movement is going to have. So for example, on this southbound movement, we put in a dual left turn lane, and it assumed that we wanted 1 turn bay on either side. However, this is more of a the right and the through have the turn or are the through lanes, and then both left lanes have a turn bay. So what we're going to do is on this southbound leg, I'm going to increase the number of left-hand side turn bays to 2, and I'm going to reduce the right-hand turn bays to 0. So now when we look at our network, we have our double left turn pocket. Northbound, it looks fine. Eastbound, we need to have dual left. And if your opacity is turned on, you can actually see when I select the column, it'll highlight the lanes that we are editing here. Okay. All right. The next step I'm going to do is I'm going to configure the length of the turn bays. And Vistro makes this pretty straightforward because we have a nice little measuring tool right here. So if you don't have an exact distance, you can take the measuring tool and you can just measure the aerial imagery. I'm going to move this intersection just for a second, so it's a little bit easier to see this turn bay. So for this southbound turn bay, I'm going to measure the distance of the turn bay to the stop bar. So in this case, we're looking at about 220 feet. So what I'll do is I'll take this southbound turn bay and I'll configure it as 220 feet, and it will extend that turn bay back to the beginning. All right, the next thing we have is the other turn base for the northbound. So I'm just going to do that really quickly. So we have 175 feet for the northbound. Here we have about 285 feet for the westbound. On this side, we have about 280 feet as well. All right, so now that we have our turn bays added, again, I'm working my way top down. So here we have, the next thing I'm going to cover are the medians. So looking at the aerial imagery, it looks like most approaches have a median except for the northbound. So I'm going to turn on the median for the northbound. Now again, Vistro has some default settings that can be changed, but the default for now is just 10 feet. So we look, and 10 feet looks about right for the southbound median. If I line everything up here, it looks about right for the westbound median. But for this eastbound median, it looks a little too wide. So I'm going to just change the median width to something like 8 feet. All right. Now we have our median widths set. We can set our speeds on the approaches. So for north and south on this particular network, north and south, these are going to be 25 feet. And you'll notice that I'm using a multi-edit feature here. That's as simple as I just left click and drag to highlight both cells. East and west is 35 miles per hour. Okay. Continuing on down, I accidentally skipped over the approach offset. Here we can see that these approaches aren't quite lined up. So what I'm going to do is I'm going to offset this northbound approach. I'm going to just look at 10 feet. We can see that it wasn't quite far enough, so I'm going to do another 20 feet. There we go. There we go. All right, so now we have the approach geometry, the basics of the approach geometry set. And it looks like we have crosswalks on all approaches. So here you can define whether or not you want a crosswalk on your approach or not, and you can see that it's indicated by crosswalk zebra striping. Lastly, we need this right turn to be channelized for the westbound movement, so I'm going to select channelized right turn. In this case, it's not going to be a signalized one, it's going to be a yield right of way. Here we can edit the channelized right turn radius to adjust the radius of the channelized right turn. And that is the basics of adding intersections. So again, to recap, we started by adding these two basic intersections to the network. Again, you'll click the Add Intersection button here and select the intersection type that you want. And then we proceeded to add the physical geometry to the approaches. We covered lane configuration, turn pockets, approach speeds, approach offsets, medians, and channelized right turns, as well as crosswalks. So we're going to turn it. I'm going to turn it back over to Adam, and he's got a poll for us to take.
Yes, thanks, Levi. While everyone's on here, we wanted to get a feel for what everybody's experience level with Vistro is. So please go ahead and answer the poll. All right, it looks like we have a pretty good mix of different levels of people who've used it before. All right, just also, while we're taking a quick moment here, I want to let you know that we're having another PTV Talks upcoming on April 16th. This is going to talk about simulating airport operations. So we will have a link going out in the follow-up email for this webinar, so please register for that. And also coming up on the 23rd, we have another installment of tooltips, which will focus on the next part of the Vsim DTA, part 2, parcel routing, as well as node and link evaluations. So please register for that as well. It gives you some good, great hands-on tips for working in Vsim.
All right, thanks, Adam. And again, for that DTA, we have part 1 We've already done part one, but if you go to our website, you'll be able to find a recording for part one. All right, so going back to Vistro basics, again, we covered our basic geometry, and now we're going to move into configuring our existing demand and our signal timing patterns for a signalized intersection. Sorry about that. Okay, so jumping back into Vistro, we have again another intersection that is already configured with geometry. Moving into the volumes tab, again, our workflow panel kind of guides us along the way. So we're working left to right along this workflow panel. We already did our intersection setup. So now we're going to move into the volumes tab, where we can configure the different types of volume of trips that are coming through our intersection. So here I'm going to activate a graphic overlay that can help us edit our network. So the first graphic overlay I'm going to edit is the show turning movement volumes. And here we see it's selected as base volume input. So we'll be able to see these update in real time. You can also edit the volumes by clicking on the arrows and typing in a value here, or you can click directly on the table on the side in the workflow panel to edit the volumes there as well. Okay, so going through and editing the volumes, again, we're not going to talk about every single one of these parameters, but I'll hit the key ones for the basics. In future webinars, we're going to be going through things like traffic impact analysis and other modes. So we will be hitting this traffic impact analysis demand and other modes in a future talk. Just note though that everything in this tab kind of works top down from a calculation perspective. So we'll be starting with the base volume input and then working our way down. And you'll see that different factors feed into subsequent calculations. So you'll add in your base volume. It's broken up kind of into your existing conditions volume here, and then your TIA demand, which then feeds into your future total volume, to which you can then apply things like peak hour factor and adjustment factors and right turn percentages and things like that. All that cycles back around to our total analysis volume, which is the final volume that is used in the actual analysis method. In this case, we'll be using HCM 6 edition. So after we've placed our different volume types into our network, we'll see that the total analysis volume might look a little bit different than your actual counted base volume. All right, so to start, we're going to be looking at the base volume input. Now here I'm going to be entering in some basic turn counts. And usually the base volume input is representative of your existing counts that you've done on the network. So here I'm just typing in the actual counted volumes that we have on this intersection. Again, instead of typing into the workflow panel here, I could also just select the arrow that I wanted and type in a value, and it will automatically update from the arrow. So I can come into my eastbound left, for example, and type in 250 trips into my base volume, and we can see that it updates there. So just depending on what you're more comfortable with, if you prefer to work in the workflow panel, you can edit it directly here, or you can click the actual arrow on the screen. So eastbound through is 21, 25. Eastbound right is okay. So again, our base volume more or less kind of represents our existing counts or the very base volume with no adjustment factors applied to it. And we can see as of right now, since we haven't applied any other adjustment factors, our total analysis volume is identical to our base volume on all approaches. Now we can go in and we can start to apply heavy vehicle percentages. So again, I'm using our multi-edit feature here by left click and dragging across all the cells that I want to edit. And then I type in the number I want and hit enter, and it'll update all the cells. Here we have a growth factor. So if I were to type in something like 1.05, we can see that it will actually take our base volume base volume input and apply the growth factor to it. So we can see the total analysis volume has actually been adjusted accordingly. In this case, we're modeling our existing conditions, so the growth factor is actually just going to be 1. But we do have a multi-change feature where if you were to copy this scenario into a future condition and you wanted to apply global growth factor throughout the network, you can use the multi-change feature to edit the growth factor as well. Again, moving our way top down, the next step would be to add our TIA demand. But since again, we are modeling an existing condition for now, I'm just going to move past the TIA demand. I'm going to minimize it just so that it's kind of out of the way. Again, we'll be covering TIA specifically in a future webinar. All right, the next one I'm going to be looking at is the right turn on red method. So we have 2 different methods for right turn on red. We have an absolute value selection where you can edit or you can enter in a specific number of counts. So here we have 25 right turning vehicles on this northbound right, and I can say, okay, 10 of those are turning right on red. Or I can switch over to a percentage value and then we can type in a specific percent. So in this case, a 16% right turn on red percentage, and it will automatically adjust. If I were to come back and scale my right turn trips, it would automatically scale my right turn volume. Okay, so now I've entered my right turn on red percentage, and we can see that the actual total analysis volume again is affected by our right turn percentage. Working our way down, top down, we can see, okay, we have our base volume input, we have our heavy vehicle percentage adjustments, our growth factor is 1, so nothing's being adjusted. And then here's the first actual adjustment that's happening. And we can see that the next cell down below is the total hourly volume. So it's taken into account everything above it and factored that into our current total hourly volume. You'll notice that this number is italicized. That means that it's being calculated, so I cannot edit this function or this value. This value is calculated from the above entries. Next, we have our peak hour factor. In this case, for the northbound, 0.98. Same thing for the southbound. And then for the east and westbound, 0.92. So now we have our peak hour factor adjusted here, and we can see the 15-minute and total analysis volume have been automatically calculated. So from a volumes perspective in the basic inputs, this is kind of the minimum input that you'll want to enter. Again, we'll come back around in a future webinar and cover TIA demand. When we input our trip generation, trip distribution, and trip assignment into the network, it will automatically feed those trips into our site-generated trips that will then be automatically calculated into our total analysis volume. Similarly, with our other modes, we'll be covering pedestrian and bicycle volumes and local bus stop rate in a future webinar. Okay. So now that we have our intersection setup done and we have our basic volumes for our existing conditions entered into the network, the next step we're going to do is we're going to enter in our traffic control. So I'm going to switch to the next intersection. This intersection again has had its demand already placed. It already has the intersection setup completed. So it has all of its lane configurations, its lane widths, its pockets, all that stuff has been edited. We have our volumes. Again, we have our base volumes, peak hour factors, right turn on reds, and heavy vehicle percentages entered into the network. We could use the graphic overlays to show us different things. So for example, I can see the difference between my base volume input versus my total analysis volume. I'm going to turn down the background map just a little bit so it's a tad easier to see. So here we can see the volumes for our background geometry versus our base volumes and our total analysis volumes. All right, next thing we're going to do is we're going to go into the traffic control tab here. So in this intersection, I have a basic signal timing entered, but if we didn't have a basic signal timing entered, we could quickly optimize. So for example, if I go back to this intersection, we have our volume and our demand entered into the network. All I'd have to do is I'd have to come in and first select which intersection, what our left turns are going to look like. So we have a protected left on the north and south, and then also protected left on our east and west. We will configure then our what our cycle length is going to be. In this case, we're going to be doing a time of day coordinated pattern, but you can also select between a free running or a isolated time of day pattern intersection. We're going to be running off of a fixed time actuation type, but you can select semi-actuated or fully actuated as well. You can set the offset and the offset reference here, and then your permissive modes. Again, the general workflow will be working your way top to bottom. So once you have this set up and you have selected your control type for your left turns and your right turns, so you can configure an overlap, for example. The next thing we can do is we can say, create default signalization. So you can come through and you can manually enter in the phasing here, or you can create the default signalization and select whether you want leading or lagging left turns. And it will automatically throw in a basic signalization onto your intersection, just so that you can get the basic timing, and it gives us our splits as well. So again, that's just this little traffic light up in the corner, create default signalization. I'm going to turn off this show turning movement graphic overlay. I'm going to turn on the signal groups graphic overlay. So here we have a graphic overlay that shows which signal groups are assigned to each approach. If you were to manually edit the ring and barrier groups, for example, you can switch your phases positions by just using this drop down below. To make it a little bit easier, you can set up your ring and barrier sequence. And if you want to switch lead and lag, you can also just use this drop down for lead lag on your left turns, and it'll automatically switch it in your timing diagram here. I'm not going to go through all of the details of the signal timing, but here we have the minimum green, maximum green, amber, and red, and split timings. These are all entered when I click the create default signalization. You can define your own default signalization in the edit menu under global settings. One other nice little feature about Vistro is it gives us this little status check for our calculation status. So there are 3 different symbols that can be shown here. It could be a red X. So if I were to go back to a different intersection, it would show this red X because there's a lot of things that I didn't edit. For example, there's no signal groups defined on this particular intersection. If I come back to the intersection I just edited, we have this yellow triangle. So I can click on this yellow triangle and it'll tell me, okay, what is potentially wrong with this intersection. In this case, it's the length of the crosswalks was not set. So I can go through, and this is fairly common if you haven't set the crosswalk length on your intersection, and you see this little warning. There's an easy fix. You just come back into the intersection setup tab. You can turn off your crosswalk and turn it back on, and it will automatically calculate the crosswalk length for you based on your lane widths and your median geometry. Once I have cleared those errors, we'll see a green check mark. So this tells us that we, from the perspective of the current analysis method that we're using, we have everything entered to do the analysis. Now, this isn't saying that it's been entered correctly. This just means that everything has been entered. So you'll still want to do some QA, QC on your model to make sure that you've entered the values correctly, but they are in there. One neat little feature, if you're looking at your model as a whole, is at the intersection level, you can actually show the ICA check on your different intersections. So you can see which intersections you still need to enter different values in for. So this is our current intersection, and we can see, oh, there's an intersection here that has not been entered correctly, or these two are missing some components. So Vistro has some nice functions and tools to help us perform some QC on our model as well. Okay, so now that we have our signalization entered into the network, we have all that we need to do the basic analysis on the network. So if I move over to this intersection here, this is the last intersection in this chain. We've gone through again and set up our intersection with all of our physical geometry. We've entered in our turn counts and our adjustment factors to generate our total analysis volume. And we've entered in our signal control. Here we have a 120-second cycle. We have all of our default timing set up. We have our split timings set up. Now we're ready to perform analysis on the network. We see we have this green check mark so it can do the analysis. The convenient part is the analysis is already done. Once you've entered in these values, all you have to do is scroll down in the traffic control tab, and you can see that after the signal timing section, it immediately goes into our lane group calculations. So here we can see it's pulling our cycle length and then starting to calculate our effective green time and our green time per cycle values, which then again, working our way top down in the list, it's always calculating top down. It takes those effective green times and green times per cycle from our lane group calculations, and it feeds that into our saturation flow calculations. Within the saturation flow calculations, we can see that I'm going to expand this a little bit just so that we can see all the parameters and their names. We can see that we have our base saturation flow per lane. This is again being pulled from our global settings, but you can always override that on a specific approach. And then it goes into our lane width or our different saturation flow calculations. You'll notice on the side here that we have variable names for each one of these. This is pulled from the specific analysis method that you're using. In this case, we're looking at HCM 6th edition, but we can also run through a model with HCM 2010 or 2000, and you can do different analysis methods on different intersections. So this isn't a global setting, this is an intersection specific setting. And so these variable names are pulled directly from that. So the idea there is that you'd be able to, if you wanted to double check the calculations or something wasn't looking quite right, you could pull up your copy of the HCM 6th edition and go through and look up how the calculations are actually done. from that specific analysis method and kind of do a hand calculation and validate these results. So in the saturation flow section, it comes down and it comes out with a calculated final saturation flow rate here for each movement. And then it feeds that into our capacity analysis. So here we have our entered total analysis volume that is pulled from our total analysis volume here. And then here's our saturation flow rate that was calculated from above. We have our capacity calculation, our green time per cycle, and our volume to capacity ratio calculated. So it goes through and it does its capacity analysis, and then it spits out our different results. So we have our lane group results. So here we have our queue lengths for our 50th percentile queue and our 95th percentile queues, as well as our lane group level of service, delays, and volume to capacity ratios. And then we have down below, we see that it's doing analysis on the movement level, on the approach level, and finally on the intersection level. So you can get the analysis on different levels of the network. Visually, we can get these exact same results here. So I can specify, okay, I want my movement-based level of service, or I want my intersection outputs. Or you can even do your approach outputs. So you can look, depending on your graphic overlays that you want to use, you can pull out different analysis here. We're going to dive deeper into these different analysis methods in the future, in future webinars, including how to print out reports for your scenarios. Okay, so that is the basics of Vistro. Again, we've entered intersections into the network. We have configured the basic geometry. We've gone through and edited our existing conditions demand, and we've put in some basic signal timing and looked at the analysis. So what I'm going to do is I'm going to turn it back over to Adam. For the Q&A section.
All right, thank you, everyone. Now would be the good time to go ahead and put in your questions in the question box if you haven't already. And I think Bill is going to take over and answer some of these questions.
Yeah, thanks, Adam. Thanks, Levi. Excellent presentation. Thank you, everyone, for joining. Thanks for such activity in the chat box, in the question box already. Lots of people have lots of really great questions. You'll notice a lot of them have been replied to, but they can be expanded on, and hopefully, as most of you were watching the demonstration and hear some of these questions, it'll spur some more questions that you may have. We have about 15 minutes left. Whatever we don't get to during this session, we'll make sure that we follow up with after the fact, and also a number of these kind of feed into some of the topics that we'll be covering over the next 7 sessions or so throughout the rest of 2020. We don't want to make you have to wait until December to get your answer, of course, but do know that these things can be answered quickly, and also we'll cover them throughout the course of the various PTV talks. So with that, what I'm going to do is kind of read through a few, kind of sort through some of the questions and throw them out there to the panelists, Levi, myself, and Adam Lynch, and then we'll just work our way through at that point. So one of the questions had to do with what type of intersection analyses that can be done in Vistro, and as Levi did show a little later in the presentation, there are a number. Levi, feel free if you want to, as I'm talking through this, to just kind of show it on screen as I'm doing that. But we've incorporated a number of different methodologies within the software, including the Highway Capacity Manual 6th edition, which is the most recent, and then 2010, 2000, and then some other alternative methods that are used often in planning contexts, like ICU for intersection capacity utilization, or even the TRB's Circular 212 methods. So that's a great question. Adam Lynch, do you want to address for the group? Question came in about other types of interchanges such as SPUIs or DDIs, or even maybe a CFI, and note that we'll have a special session on that a little later on too.
Yeah, those types of intersections can be modeled into Vistro. Now, depending on how you want to model it in Vistro, that's kind of up to you as the modeler. Several methods with like a DDI, you could use multiple nodes to kind of model the different crossovers and ramp junctions, and it's the same thing with the SPUI. Depending on how the SPUI is set up, you could use multiple nodes, or you could just use one single intersection to model the SPUI and just go that way with it. As far as CFIs, I haven't done one in a while, but it's kind of the same method there. You would just import multiple nodes where the crossovers are, and we'll show that later on in one of the further sessions.
Yes, excellent. Levi, a quick question was just on changing intersection numbers. Can you just show how to do that in there? And I apologize if you did already. I've been trying to man the Q&A.
So you can change the intersection number just by double clicking on the number up at the top here. So I can change this to like 105, for example. That's pretty frequent because when you drop in an intersection, it will give it a default number. It'll always start at 1 and then go 2, 3, 4 from there. But frequently what you'll want to do, what a lot of people will do, is they'll change the intersection ID number to match whatever the ID number is for the city or MPO that they're submitting the model to. So that way it shows up in the reports with the correct intersection numbers. Perfect.
And then a couple of questions on some of the background images. Just, is the Bing live that you're showing, or is it a static image? And then follow on to that, Levi, I'll let you show that. And also follow on to that is, could you also just import in a static image, from either a search engine or, what about even a, architect site plan or something like that? Can we support that?
Yeah, so the internet map is more or less live. It's live in the sense that, it's global, so you can go anywhere, and it's default in the network as Bing. We also have access to OpenStreet aerials as well. So if you prefer OpenStreetmaps, you can look at the OpenStreetmaps as well. Now, is it as up? Now it's kind of, when you're using the Bing, there's always the caveat that it's as up to date as Bing is up to date, right? And so that just depends on how frequently Bing updates their aerial imagery. So if you don't have aerial imagery that is up to date, or maybe there was a recent build or something that was put in, you can always drop in a background image. And this background image, it can be it could be a bunch of different file formats. But yeah, you can insert a background image and then scale it so that way you can reference that, and it'll sit underneath. It'll sit over the top of the back of the aerial imagery and underneath your network, so kind of in between those two layers. One note though is that the map is that you'll want to do that in the base scenario. So if you are using scenario management, you'll want to put that background image into your base scenario.
And that's a really good point for those of you that are using or are going to jump into things. We do have some sessions coming up, and one of which we'll start in our next session when we go more. We're going to go deeper into the intersection parameters and analyses. Then we will look at scenario management as one of the key elements to that. Clearly, everything Levi did today will get you through an existing conditions analysis for a given scenario or a given time period. So, of course, that's great, and that's the starting point. The next thing that you'll need to be making use of is a scenario manager, and when that comes into play, it's both considering the things that vary by scenario, like timings and volumes, but also the network elements. And so we have some really great ways that can be managed in Vistro. The only thing I'll say at this point is to understand that what we call the base scenario is really a special case. And like Levi said, things that you edit or do in the base scenario will then flow through or affect all the additional scenarios. So that's the place that you want to do things to maximize your returns, right? Or to have your efficiency gains, is to do a lot of your work under the base scenario so you don't have to repeat it multiple times. Okay, so moving into a couple other questions here. One question that came up was, when do you use a tool like Vistro compared to Vsim? And really, there's lots of different times that you might want to use Vistro. At its core, Vistro is in the deterministic class of software. So if you look at FHWA, they have some traffic analysis tool guidelines, and they kind of list out where different software classes fall into the different types of analysis that you're doing. So Vistro really at its core is a deterministic analysis tool, meaning it implements things like the highway capacity manual or like the ICU method. And so if you're doing those levels of analyses, then that's right in the heart of what Vistro performs. Beyond that, then we make nice transitions to move into a software like Vsim if you do need to simulate after that. There is some bigger picture questions of when do you simulate versus accepting HCM results, and those are kind of bigger picture topics that we can talk more about as we get into some of the sessions. And a classic case would be something like left turn bay overflows or things like that. And none of it's a limitation in Vistro. It would be a limitation in any of the underlying methodologies. So highway capacity manual, which is a great tool. I'm a committee member for the highway capacity quality of service and chair the interrupted flow subcommittee. It's an excellent tool, but like all tools, it's when do you use the right tool for the right job? And a lot of times that's where those decisions get made. Is an HCM or Vistro type analysis sufficient, or do I need to move into simulation? The great news, of course, is we have tools to cover the full range of your analysis needs. So we can talk more about that, definitely. And I'll just move on to another question here. Adam Lynch, can you talk a little bit about some of the imports and export features that we have? I know that's a bit of an advanced feature, but maybe you can at least let the appetite for that.
There's been quite a few questions about the import of Synchro. Yes, we do import Synchro files, the CSV file, which is the combined CSV. We import that into Vistro, and I just released a video on that, I guess it was last week already, about that import, and you can search for that on YouTube. We also have import from Openstreetmaps. So if you have a valid.osm file, you can import Openstreetmaps data into Vistro and clean it up a little bit, and then you can get a network pretty quickly. Some of the other things you see, there's the values table. That was another question. Can we import volumes? You can do that through the values table and import base volumes. You can import the right turn on red volumes and various volume sets. And the way the table is structured, it lists the number of intersections in the one row view, and then the columns are actually the approaches with left through right. So it's a really easy table to use when it comes to importing volumes. We do have the imports and exports into our own products within the Vision suite, the traffic suite. So we can import to Vsim, and actually Vistro is pretty much a Vsim file. It just has a .vistro at the end instead of version, but it's very similar, shares the same data structure. So that merger into Vsim is quite good. And then it can also go from Vsim back to Vistro pretty well. The conversion from Vistro to Vsim, we can go that way because we're taking our node link structure and breaking it out into Vsim geometry, but we can't go back from Vsim to Vistro. That's
right, excellent.
Import export 101.
Perfect. Well, we have about 5 minutes left. There's a few more questions that I want to get to. One of the comments that I wanted to address and in the Q&A had to do with concern about, with all the great features that Vistro does, that consultants can still be limited in being able to use Vistro because municipalities have not yet specified Vistro on their approved software list. And so great question and great call out of, right at the end says, what is PTV doing to get Vistro onto the approved software list? So really that is it's good to mention. We are continually working to make our software known to agencies throughout the US and Canada. within our sphere of influence and making them aware of all the features and all of the calculation methods that we have, that we're HCM, that we implement the HCM methods, that we can give similar results to for people to use as any of the competition, and we have certain points where we know that we are doing implementation better. So basically, that is what we are doing. However, what we always reach out for is our user base, that people that really like using this tool help us to be aware of who you are dealing with specifically, so that we can focus our attention to better serve your needs. So, you know, it's a large country and a large continent, and we're making our way through it. But if you know a particular jurisdiction you work with all the time that is unaware or needs some extra emphasis from us at PTV, we are extremely happy to do that. So please reach out and help us. We'll get there eventually on our own, but it's more beneficial for us to know specifically who you're dealing with. So if you can let us know that after this, that's great. We'll be happy to work with you in getting that known. One of the things for HCM, just to point out, I've mentioned it a couple of times now, there was a couple of questions in the chat regarding getting HCM level of service and delay and output. And so we showed some of that on screen. There's also outputs to PDF files, and we're going to go over those more in our next session in terms of detailed tabular output. But the other thing I want to point out is through our involvement with the committee and implementation of the HCM, that we are implementing the pure HCM methods for signals, two-way stops, always stops, and roundabouts. You will not find certain geometries in Vistro where we pop up a thing that says, hey, we can't handle this because HCM doesn't do it, because there are cases where we, by implementing the full method, are able to calculate that. And so I know there seems to be a misconception in the industry sometimes that a particular software does highlight what a particular method can or can't do. And I would just say, be open-minded to that. There's not those limitations. The only way that you would find out a problem in Vistro is if the calculation isn't occurring. So, and that's pretty rare. So we implement the pure HCM for those methods. And if you have any questions or follow-ups on that, we're happy to work through that with you as well, or your agencies, or if you are an agency, we're happy to work through that. All right, with that, it is 9:59. I'm going to scan quickly. Maybe I'll just say, Levi, Adam, do you have any closing things that you wanted to address at this point? Any of the other questions we will get to after the fact, and we'll also highlight during other upcoming PTV talks. But Adam, Levi, any closing thoughts? All right, Adam Groves, you want to close us out?
Yes, thank you very much, Bill, and thanks again to Levi and Adam Lynch, and thank you to everyone for attending. We really appreciate it. As I mentioned before, there will be a recording going out in the next day in an email. You can also check out ptvtraffic.us to view this recording, as well as previous recordings for other PTV talks. Also, make sure while you're there to check out the events tab so you can keep up to date with all the upcoming sessions. Thank you again so much for attending, and we look forward to seeing you next time.